series 1 plus x divided by 1 factorial plus x squared divided by 2 factorial plus x cubed divided by 3 factorial, so on up to x to the power n divided by n factorial, and again so on up to infinity. So this is uniformly convergent. We need to show this on closed interval -1 to 1, which means x is belonging to the closed interval -1 to 1. From here we get that mod of x is less than equal to 1, right? There is a very beautiful note written over here that 1 divided by n factorial is always less than equal to 1 divided by n square for n greater than equal to 4. So the result is valid for n greater than equal to 4. And then there is a remark written over here that if summation n starting with a positive integer capital N to infinity on mod of u and x, that is less than equal to summation n starting with capital N to infinity on mn for all x belonging to E, where this right hand side infinite series is convergent for some positive integer capital N. Then the left hand side series, the infinite series, summation n starting with capital N to infinity u and x converges uniformly on E, and hence the infinite series that starts from n equal to 1 converges uniformly on E. This is nothing but your Weierstrass-Zamm test only. In Weierstrass-Zamm test we have studied that the series starting with n equal to 1 up to infinity, right? But this remark says that no matter, you can also start n with any positive integer capital N to infinity, then also the result is true. The Weierstrass-Zamm test is true. So this remark is helpful in this case. So this is your given series, which can be written as in summation form n starting with 0 or 1. 1 can be written as x to the power 0 divided by 0 factorial. So we write here n starting with 0 to infinity. X to the power n divided by n factorial, right? Okay. Now let's consider this series x to the power n divided by n factorial mod. I need to start this series with the positive integer n, that is equal to 4. Why I am taking 4 over here? Because I am having n factorial in the denominator. And just right now we have studied that 1 divided by n factorial is less than equal to 1 divided by n square for n greater than equal to 4. That is why I need to start the series with n equal to 4, because I am going to use that note over here. So considering this, which can be further equal to summation n starting with 4 to infinity, this is mod of x to the power n divided by n factorial, which is also equal to n starting with 4 up to infinity, mod of x to the power n divided by n factorial. And because it is given that x is belonging to the closed interval -1 to 1, that means mod of x is less than equal to 1. So let's apply this over here. So this right hand side is further less than equal to summation n starting with 4 to infinity. This is 1 divided by n factorial, right? So this is further less than equal to summation n starting with 4 to infinity 1 divided by n square, because of the note that 1 divided by n factorial is less than equal to 1 divided by n square for n greater than equal to 4. We get that this is further less than equal to summation n starting with 4 to infinity 1 divided by n square. Reason: 1 divided by n factorial is less than equal to 1 divided by n square for n greater than equal to 4. Please recall that summation n starting with 1 to infinity 1 divided by n to the power p is convergent for p strictly greater than 1. And here I am having the power 2, that is strictly greater than 1. So therefore this series is convergent, right? And because the right hand side is convergent, which is actually your mn, and because the infinite series on mn is convergent, so by Weierstrass-Zamm test we say that this series is uniformly convergent. So let's write this. But summation n starting with 4 to infinity 1 divided by n square is convergent. So therefore, by Weierstrass test, the series n starting with 4 to infinity x the power n divided by n factorial converges uniformly on the closed interval -1 to 1. So from here we further say that thus the given series summation n starting with 0 to infinity x the power n divided by n factorial converges uniformly on the closed interval -1 to 1. By the another remark, please read that. The point in the blue bracket, that is very important. Let's read the remark first. If summation n starting with capital N to infinity mod unx less than equal to summation n starting with n to infinity mn. In the proof, we have started the series with n equal to 4, right? Where the right hand side summation n starting with 4 to infinity mn is convergent for some positive integer n. Then the infinite series that starts from capital N, that is 4, u and x converges uniformly on E. From here and hence, the infinite series that starts from 1 on u and x converges uniformly on E. But because in our case we have started n with 0, that is why we have written here that the given series summation starting with n equal to 0 to infinity converges uniformly on the closed interval. Right? Clear? Okay. Thank you.